Welcome back to part 4 on composition of functions. We need to find the domain of each of these given functions if we use f of x equals x squared minus 4 and g of x equals 4 minus the square root of x minus 6. In the first function composition, or sum of functions, we have f plus g of x. Notice that we are not dividing anything, but we do have a square root in g of x. Now let's take a look at each one of these functions separately. The domain of f of x is all real numbers, negative infinity to infinity. For g of x, we have a domain that is a little more restricted. Remember, we take the radicand and we say that that radicand must be greater than or equal to 0. That will ensure that there will be no negative numbers under the radical. So when we solve for x, we get x must be greater than or equal to 6. So our domain is from 6 to infinity. When we add the two functions together, remember that the overlap in the domains is where the sum of the functions exist. Therefore, if I were to graph the domain of f of x, it would be the entire number line. However, if I was to graph the domain of g of x, it would be from 6 to positive infinity, where if I highlight just that interval, it would be from 6 to infinity. So the function f plus g of x has a domain from 6 to infinity. We can also write this f plus g of x as a composition, or the sum of the two functions, where f of x is x squared minus 4, and we add that to 4 minus the square root of x minus 6. When we combine like terms, the 4's add to 0, and we get x squared minus the square root of x minus 6. Now we have g of x minus f of x. This function is similar, only we're subtracting the other function. So now we will have 4 minus the square root of x minus 6 minus the quantity x squared minus 4. We will have 4 minus the square root of x minus 6 minus x squared plus 4. If I rewrite that, I will have 8 minus the square root of x minus 6 minus x squared. Once again, our domain for this function will be on the interval from 6 to infinity, because once again, it's the overlap of the domains, and the domains have not changed. The way we have combined them has. In part G, we need to find the product of f and g of x, not to be confused with f of g of x, and we will rewrite these as two binomials multiplied together. If we multiply these out using the first outer inner last model, we will get 4x squared minus x squared square root of x minus 6 minus 16 plus 4 root x minus 6. If we look at the restrictions on our domain, again, it's nothing new. We still have the restriction as a square root of x minus 6. which means the domain of this function will be from 6 to infinity. Let's take a look at h. H is f over g, or f divided by g of x. This is f of x over g of x. Simplify this or rewrite this. F of x is x squared minus 4, and g of x is 4 minus the square root of x minus 6. It is very important to notice that at this point we have a square root in the denominator. This is going to cause some issues because even though it's okay to have a 0 in the radical, we also have to throw out any points at which the denominator will be 0. So now the restrictions on our domain have gotten more complicated. We could say that 4 minus the square root of x minus 6 cannot equal 0. If we solve that, we'll get 4 cannot equal the square root of x minus 6. If we raise both sides to the second power, that will give me 16 cannot equal x minus 6. Therefore, if I add 6 to both sides, x cannot be 22. We also have a restriction on the square root here, the x minus 6. We can't have any values that will be negative under the radical. That means any numbers less than 6 will cause issues as well. So we know that x cannot equal 22, but we also know that x must be greater than or equal to 6. If I write this as a whole domain statement, the domain of f over g of x can only exist from 6 to 22, not including 22 because we know that will cause a 0 in the denominator, union 22 to infinity. Let's take a look at g divided by f of x. We can rewrite this as 4 minus the square root of x minus 6 in the numerator and x squared minus 4 in the denominator. For this particular division, x squared minus 4 should not equal 0. That means x squared cannot equal 4. So x cannot equal plus or minus 2. We already know that if we have any values less than 6, we will cause problems in the numerator. And so by default, if x is already going to be greater than or equal to 6, and x cannot equal plus or minus 2, we have already restricted our domain via the numerator's radical. So we don't have to worry about the denominator equaling 0. So the domain for g over f of x is again anything from 6 to infinity.